शर्मा जी।
जी डॉक्टर साहब, बिल्कुल 2 मिनट में स्टार्ट कर रहे हैं, 2 मिनट में।
ओके 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 ओके।
जी। नंदिनी प्लीज स्टार्ट करिए। नंदिनी।
हाँ जी सर।
हाँ, स्टार्ट
सर
करिए।
ऑडियो वीडियो क्लियर है?
हाँ, क्लियर है, प्लीज।
Good evening, everyone. Happy Ganesh Chaturthi to one and all. So, on the behalf of entire AgriMeet Foundation, this is Nandini Sharma, and I extend a warm welcome to you for the Faculty Development Training Annadata 2025. And I feel truly honored to welcome our distinguished speaker today, Professor Dr. M. Pandyan. Dr. Panyan is a celebrated legume breeder, academic leader, and visionary in agricultural sciences. He has served as Dean of two agricultural colleges and research institutes under TNAU guided research stations and led as ICR KVK program coordinator. With more than 4 decades of service, his work has touched not only the scientific community but also the lives of countless farmers. Sir has been instrumental in the development and release of 17 crop varieties in pulses, oilseeds, vegetables, and fruit crops, improving productivity, ensuring food security, and directly benefiting farmer families. His varieties of black gram, green gram, red gram, and groundnut are widely adopted and appreciated at grassroots levels. Beyond research, Dr. Pandyan has always kept farmers at the heart of his mission, mobilizing resources, organizing vocational trainings for rural youth, establishing FPOs, and reaching farmers through advisory services via TV, newspapers, and digital platforms. His passion for bridging science and practice is what makes his journey so inspiring. He has authored over 178 research papers, 12 books, and 20 book chapters, and guided many PhD and postgraduate students and led impactful projects across India and abroad. For his outstanding contribution, he has been honored with over 30 prestigious awards, including the ICR ISGP Award 2023, Dr. APJ Abdul Kalam Best Scientist Award 2022, and Lifetime Achievement Award. His innovations has even contributed to Tamil Nadu receiving the Krishi Karman Award, proud milestone for the state and the nation. Sir, it is indeed a privilege for us to have you here with us today. Your dedication, your leadership, and your commitment to farmers truly inspire all of us. With great respect and warm regards, I extend a heartfelt welcome to Professor Dr. M. Pandyan. Over to you. The session is yours. Thank you so much, sir.
Thank you, madam, for a brief biodata on me. Can I start?
Yes, sir, you can start.
Yes, Doctor Saab, please.
Okay, I will start, but slide is not open. But anyhow, introduction, I would like to say. First of all, I would like to say thanks to Dr. Ankush Sharma for giving me the opportunity. So, good evening to every one of you, those who are connecting with us. I am very sorry for not attending the first day presentation because I have some important interview at Meghalaya, so I could not attend the presentation on the day. I am extremely sorry once again for the inconvenience. Today I am very happy to connect with you to present my topic FDR, that is Faculty Development Program on Conventional Plant Breeding Approaches in Various Crops. In that, I'm going to focus on two crops today, the white crosses in legume crops, groundnut and mung bean, to develop resistant donors for biotic resistant to sustainable agriculture. So I am from Dr. M.S. Swaminathan Agriculture College and Research Institute, Tamil Nadu Agriculture University, Tanjavur. Ankur, can I get the slide?
So
Yes, change.
slides are moving, sir.
It is not coming to me,
Uh,
but in my system one by one I will going on.
uh,
For me, it is not. It is not for me.
अंकुश सर
नहीं
आपको
सर, स्लाइड मूव कर रहा है, मुझे
Slide
भी
is
दिख
not
रहा है सर,
displayed. Slide is not
मुझे भी दिख रहा है,
displayed.
स्लाइड्स मूव हो रहे हैं.
For me, it is not comes na.
अच्छा, आपके पास नहीं आ रहा, क्या इशू हो सकता है रोहित जी?
सर आपने सिस्टम पे लॉगिन किया है ना?
Okay, from starting from my slide na.
Yeah, it's okay, sir. I will change.
Okay.
But just like sir, when you change the slide, na, just tell me next. I will change the slide. You can read the
Okay,
slides
okay,
from your
okay.
system, but when you go for next slide, na, just tell next. I will change the slide, sir.
The first slide is wide hybridization in groundnut. Is it okay for you?
Yes, Dr. Saab,
Yes.
yes.
Okay, okay. So groundnut, everybody knows groundnut is a widely cultivated oilseed crop. It stands first in India. So it is Arachis hypogaea, 2n equal to 40. It comes under polyploid in nature, that is allo polyploid, ambidiploid. Originally it is self-pollinated, but so frequency of two-parted seed in the groundnut crop. That is due to myself is my in-depth studies on groundnut is comes to some cross-pollination occurs in that. Cross-pollination occurs in this. Most of the literature says it is glistogamous in nature. Glistogamous in nature, not like that. Some cross-pollination is occurs due to hypanthium role. Hypanthium role. Anybody groundnut breeders is in the line in the present connected with this presentation, please note it down. Please note it down. So it is comes under self-pollinated, but there is some cross-pollination is occurs due to hypanthium control. Hypanthium, it is a tuber-like structures covered fully female and female part of the flower. Female part of the flower. Some of the hypanthium, some of the varieties closed female part. Most of them are protrude. Most of them are stigma is protrude outside. So protrude outside means definitely it will get getting the other plants pollens for pollination. This is the things happen. So that every genotypes having the capable of four four germ cells, but usually we are getting two kernels only. So two or three sometimes aborted only because of this hypothetical control. So this is important point of the flower habit in the groundnut, self-pollinated groundnut. So genus belongs to Leguminaceae family. Based on morphology, geographical distribution and cross compatibility, genus is divided into 9 taxonomic. Some of the introduction I wanted to tell because everybody knows. So in depth I want to tell. Even breeders, groundnut breeders, that doesn't know about the sections, how many sections are present in groundnut group. So that I am insisting that point here. So Arachis, first section is Arachis, second section is Coloraceae, third one is Ereptoids, fourth one is Exon Herbaceae, fifth one is Petrohanthiae, sixth one is Procumbens, seventh one is Rhytomaceae, then eighth one is Trierectoids, and ninth one is Triseminaceae. So these are all the 9 section. Out of 9 section, 7 section we are working as a groundnut breeders. We are working 7 section only. Remaining the 2 section, the 8th and 3rd, is not touching. It is there in for study purpose. So we here in Arachis, IT genotype species are available. More than 100 countries having groundnut cultivations. Already I told it is diploid under tetraploid nature. It is polyploid, but it acts as a diploid in nature. Native of Brazil to Peru and Argentina, all from South America. Hypogaea is most important widely cultivated species. Hypogaea is a segmental allopolyploid. Segmental allopolyploid, that is ambidiploid. So cytologically it is behave as a diploid. So next slide we are going. Next slide. So second slide showing the particulars of section. Each section is having how much species. So in that Arachis section having more than 32 species, and other sections are having lesser in species. So third slide, same showing the sections. Same showing the section up to section triseminate. Triseminate. This triseminate, only one species are available. Only one species is available. Others having more than one species. So a large number group only in the Arachis hypogaea group. So fourth slide, based on growth habit and flower arrangement on the main axis, cultivated groundnut is divided into 2 subspecies. One is Fastigiata, another one is subspecies Hypogaea. The Fastigiata subspecies comprised of 4 botanical varieties. They are Vulgaris, Fastigiata, Perivinia, and Equisetic Anna. So these are all the 4 species, subspecies. Hypogaea is divided into 2 varieties, Hypogaea and Hirsuta. Based on the inflorescence, pod and seed characters, there are 3 marked agronomic types, Virginia, Spanish, Valencia. Among the 3, we are using most probably Spanish varieties we are using now. Valencia, you know, Virginia, you know. Virginia is a big size pod and big size kernel. Valencia is a vegetable types. Vegetable types means one pod having more than 2 or 3 seeds, or up to 5 seeds is there. So some very few varieties we are using now in the Indian level. Spanish almost maximum we are using. Virginia also we are using more. So Hypogia suspicious fastigata, vulgaris are Spanish bunch type. Hypogia, Virginia marker type. Hypogia fastigata, Valencia marker types. So these three types agronomically we are using now. So cytological and molecular studies, two diploid wild species, Arachis thurinensis and Arachis hypanensis, are the wild progenitor of groundnut, cultivated groundnut. So groundnut originated or evolved from thurinensis and Arachis hyposia. So the two species and two species having the two genome, A genome, thurinensis is A genome, hypanensis is B genomes, are coming from the two species formed to groundnut, Arachis hypogia. A single, previously many theories are there, many species involved to develop or involved to evolve cultivated groundnut species, but now confirmed the Arachis durans is one of the A genome, so that this is B genome from hypanensis. So this is comes under allo tetraploid and segmental polyploid. A single hybridization even between progenitors followed by chromosome duplication. This is naturally duplicated. So next slide is characteristics of three botanical varieties. The variety is Hypogia. So number of flowers or no flowers on main branches. This is the main character. It has alternating branching, alternating pairs of vegetative and reproductive axis and branches. So only in the inflorescence is very simple. So vegetative branches moderately to produce primary branches longer than the main stem. So growth habit spreading intermediate or erect, usually 2 seeds per pod. So pod beak not very prominent, seed size medium, runner marker type or larger, Virginia marker type. So testa color generally tan color. They are red, white, purple and variegated also exist in that. So for variegated types in the Spanish, that is our very famous variety, TNA varieties, TME7. TME7 we called as Raman Kadale. Kadale means Tamil, it is groundnut. So nuts. So Raman Kadale is so two or three types are there in the kernel. So that we called as very easily, farmers also understand that Raman Kadale. So cured seeds are dormancy, moderate, and maturity medium to late. So this is the Hypogia characteristics. Hypogia characteristics. So variety fascigata, floral axis on main stem. Whereas in previous one, flower is not in the main stem. Here, flower is in the main stem. Irregular pattern of vegetative and productive branches with reproductive branches predominating on branches, sequential branching. Inflorescence usually simple, vegetative branches sparse, primary branches shorter than the main stem, growth habit upright. 2 to 4 seeds per pod, pod beak absent, slight, prominent. These are all the very good characters on particular fascigata. Seed size small to medium. Testa color tan, red, white, yellow, purple, variegated. Pure seeds dormancy silitings and compared to that previous one. Next slides. Variety again fascigata, floral axis on main stem. Irregular pattern of vegetative and productive branches predominating on branches, sequential branching. Sorry, another third variety, vulgaris. Floral axis on main stem, regular pattern of vegetative and productive branches with reproductive branches predominating. Primary branches shorter than the main stem. Growth habit, that is upright, mostly 2 seeded per pod. 3 seeds are rare. Peak may be or may not be present. Seed is small in size to medium. Testa color tan, white, purple. Pure seeds dormant is limited. Then phenotypes. Phenotypes, basic 4 types are available: runner, Virginia, Spanish, and Valencia. These things already I told, except the runner. Runner, you know, this is long duration. It's going, it's going in the ground level. That is runner type. The runner group, it is connected with each Virginia and Spanish and Valencia, each distinct in size and flavor. Runner is have become a dominant phenotype, spectacular increase in peanut yield, so that it is long durations, automatically it has highest level of yield potential. So runner have rapidly gained with acceptance because of the attractive kernel size range. High proportions of runners are used for peanut butter. Peanut butter. This is an ordinary butter. This is a very good market now, the peanut butter. Then Virginia. Virginia have the largest kernel and account for most the peanut roasted and eaten as in shell. So already told it is a very good type, the bold seeded types. When shelled, the large kernels are sold as a salted or flavored peanut. India is concerned, we are producing this very good types, bold types we produced here and sent to other countries. From other countries making valid added product, then again imported to India. This is the situation now in our Indian conditions. So big bold size invariably we can see in Malaysia and any flight we are traveling, we can get this kind of material, all material from exported to other countries, and we are getting in the market with the highest cost. Spanish, smaller kernel covered with reddish brown skin. Widely we are using, widely we are cultivating, used for salt nut and peanut butter, but wide adaptable, right? Wide adaptable to nature of Spanish. So higher oil content than the other types of peanuts, high in oleic acid, beneficial monosaturated fatty acid. Roasted peanut, increased shelf life make it ideal for candy bars for snacks nuts. Valencia, 3 or more small kernels to a pod, up to 5. Sweet peanut and are usually roasted and sold in the shell. Excellent for fresh use as boiled peanut, natural peanut butter. But in India is concerned, we are using Spanish only as a vegetable types due to greater demand for other varieties. So most of the peanut cultigens exhibit susceptibility to in various degrees to all major insect pests. Although high level of resistance to many of these pests are found in wild species of the genus, so that we are going to exploit wild genes for improving the already existing cultivated genotypes. So this slide shows these are all the first column. Lot of wild species available in our research stations and their resistance levels. Pest, what is the pest resistance? What is the disease resistance? Yes, in the example, Corentia, the disease resistant, highly resistant for early leaf spot, and late leaf spot, highly resistant. So likewise, many resistant we are noting down here by studied. So pest and disease resistance. So this species we are using in our groundnut improvement program. So we got a very good result from that cross combinations. So first successful interspecies hybrids in groundnut, in that Hypogaea and diploid wild species, Hypogaea and Villosa or Corentina were produced by Kropovicas and Rigoni 1951. This is the pioneer person, the first hybridization successfully done in the groundnut and under other species of Arachis group. So cytological of hybrids, he found sterile triploid hybrids, partial sterile, partial fertiles, and partial hybrids were recovered. The same type of result I also obtained. So gamete is concerned, 6 to 10 bivalents, 2 to 3 trivalent, 1 to 2 quadrivalents were reported in different cross combinations, and also 20 bivalents are also is there in that, so that very good F1 seed, F1 genes and F1 generations we have maintained at right way in get a good result of the bivalent behaviors in the gametes. So segregation was irregular and percentage of strainable pollen grains varied in size. So hexaploid, pentaploids and tetraploids progenies were also recovered in natural chromosomal doubling. Among these person studies, I am also come across this kind of some of the valuable stages are available in my studies also. It is coming into that. So that's why my studies also very easy comparing the. So some of the difficulties comes. So I compared with the literatures. It is corrected the what is the result we obtained. So meiosis in hexaploid hybrids derivatives are highly irregular. So maximum of 20 univalents have been reported. These persons, the company and co-workers, for the same result also I have come across in my studies. In addition, several workers reported 1 to 2 hexavalent, 2 to 3 quadrivalent, plus trivalent, and 20 to 25 bivalents in the progenies of various crosses. So multivalents also I observed in my study, multivalent by cross combinations, some of the cross combinations. So meiosis of species hybrids, ambidiploids involving diploids, Arachis species indicated the formation of 10 regular bivalents, except in cross involving Batechicoids, where meiosis was highly irregular. The chromosomal association in intersectional hybrids also exhibited low frequency of univalent, multivalents, indicating their genomic homology. So univalent and multivalents giving the problem for it leads to sterility. But when this univalents and multivalents is not there in that, definitely we can get a good fertile hybrids. So meiosis of intervarietal crosses of cultivated groundnut indicated formations 20 bivalents during meiosis. It is normal. However, occasionally quadrivalent and 1 to 2 trivalents were observed. So because of this groundnut comes under polyploid in nature. The low frequency of multivalent configuration in these crops indicate that cultivated groundnut is effectively diploid tetraploidy. The multivalent associations can be also due to homologous pairing and formations of quadrivalent, trivalent, and univalent between chromosome of the two genomes, and when pairs of trivalents, hexavalents are observed. So now we are going to see wild species in research station, wild species lab. Lab means field lab. So one by one we can see. So this is VRI-10 for a crossing program. In middle, wild species Corentina. Corentina is the wild species. Arachis corentina is wild species. It is in the wild species garden. Wild species garden. Whenever we want, we are raising the parent near the wild species. Whenever flowers comes in the species, groundnut cultivated species, we can cross with this wild species. We can cross with both sides, reciprocal and direct and reciprocal. This is the method we are field crossing program. You have to implement it in the field itself. So middle species is the Corentina wild species, groundnut wild species perennial. Both sides cultivated released varieties for improvement of these characters. Corentina having pest and disease, especially late leaf spot and also early leaf spot. So this type of disease residents having, so we are going to cross for implementing our variety. So VRI-10 and VRI-9 we are using for improvement VRI-10, VRI-9 through wild species. So another wild species, Stenoferma. Another wild species, the same way we are going to cross. So both sides we are raising the cultivated species, then we can get very good pod, crossed pods. So during harvest of our VRA10, VRA9, so based on the breeders we have to check during the harvest. So already we are labeling or everything we have to done in the crossed parts. So crossed flowers already tagged during harvest. We have to see whether our tagged pod only matured or not. That we have to ascertain. After that, you have to select. This is the crossed pod. Crossed pod always kernel is shriveled, not plumpy, not fully packed. This is the very good identity for collecting crossed pod. So other then Hardinaceae, another wild species with VRA10 and VRA9. Then Clavaretta. Clavaretta is one of the same chromosome number 2n40. Groundnut also 2n40. That is tetraploid in nature. So here also we were crossed with VRA10 and VRA9. Another species, Batisacai with VRA10 and VRA9. Then another species, Monticola. Monticola is the another 2n40. So only 4 tetraploid in nature. In wild species, 3 species having 2n40, same as groundnut, Arachis hypogaea. So Monticola, Clavaretta, and also Bellus carba. These 3 are the 2n40. Other species, out of 80 species we shown there, other species are diploid in nature. 2n equal to 20. So uses of wild species, So only because of we are transferring the biotic and abiotic resistant genes to the cultivated types. We are doing. So in that, Arachis Clavaretta and Arachis pentois are placed for grazing, and Arachis ribbons is used as a ground cover in residential area, roadside in tropical regions. Some areas, some homes, they are cultivated as a ornamental plants. 2 wild species, Arachis villogicarpa and Arachis tenosperma, were cultivated by indigenous people in Brazil for food and medicinal purpose. Albeit on the limited scale, but only a hypogaea is economically important today as a human food sources. Important, mainly Arachis species have extremely high level of disease and insect resistance that are not present in the cultivated species. So another file I am opening now. So please a few minutes.
Yes.
Okay, now it's okay. Ready for me. So wild species and crosses. Previously we are taking how we are making cross with wild species in field itself. Now we are going to see actually our harvest time, the species. So you can see I think this is the view. Second species VRA10 into Corentina. So first picture is parent VRA10. Last picture is wild species Corentina, and middle picture is hybrid. You can see here this F1 parent having more number of parts. Another parent, last third picture is the wild species, very small and a small leaves also is there, small flower, but in middle hybrid. Hybrid in that limited pod is there, limited pod is there. So limited pods, all the limited pods are original F1. In the field itself, we can select the or tag the original F1 true F1. So after only you can go for further forwarding generations you are going to do. So first of all, you have to see in the F1 after raising the F1, what are all the true F1 we have to select. Then only you have to promote to F2 generations. So this is one species. Another species, Clavarata. Another species, in middle it is a hybrid. Middle is the hybrid. There is a good variations between the both parents, intermediate, and leaf is intermediate, and pod also intermediate. So maximum we got it in one seeded pod in F1. One seeded pod in F1. So one seeded pod and seed also somewhat shriveled and still some anomalies is there. So that itself it will be considered for highly true F1s. True F1s. In the plant itself, we should know when we analyze this by experience. Readily you can fix the F1 plants. So another Clavarata species with VRA10. Then it is Batisacai. This is Batisacai. So in these combinations, F1 is very robust, but yielding ability is very very low. Then another coordinacy. Here also the F1 plant is very robust, but pod when compared to female parent, less pod. Then another Stenoferma. So here plant is robust, so the pod set is very low. Pod set is very low. So due to it is similarities, not deep similarities, there is some variations, chromosomal variation is there. So it gives the variations in F1 itself. F1 itself. So we are at 10 into Manticola. Manticola already I told 2n equal to 40, same as a chromosome of Harapis hypogaea. So tetraploid in nature. Here also there is some variations in F1. Then Corentina. Corentina, these are all the F1. The 4 plants are F1 plants, but less number of parts. Another Clavarata similar to what called the F1 is similar to wild species nature, Clavarata nature. So robust plant, leaf are very smooth, more number of leaves, just like that of perennial in nature. So the very interesting. Phenotypically, we can get a lot of idea about these cross combinations. So VRA10 into Stenoperma. The VRA10 and VRA9 is the common parent for both all wild species. So here Batisacai. Batisacai also robust plant, but less number of parts. Another VRA9 into coordinacy. VRA9 into coordinacy. So VRA9 one special character. So most of the varieties in India affected by disease, but VRA9 a nutritional rate is very good. Nutritionally, it is very good. So so I think this F1 hybrids, the pod similar to F1 hybrid, similar to VRA9 parent, but the shape and peak is very highly different. Highly different. That's only we are considered for it's a true F1s. True F1s. So with this, I can complete second file. Then third file I want to open. So VRA 6 into Pusila. VRA 6 into Pusila. So Ankur, third file, please open.
Done, sir. Done.
Okay. That is a recent study. All pictures I showed. VRA 6 into Arachis pusilla. Pusilla is one of the wild species. So these two pictures are F1. So VRA 6, one of the old variety, ruling variety in Tamil Nadu. So tolerant to foliar disease. So that the pusilla we are taking one of the aspect for some pest especially leaf miner. So another Beta-saccharide VRA 9. So F1 in the beta-saccharide having more number of parts. Then Pusilla again VRA 9. So part is somewhat different from the parent. Then another VRA 6 into Monticola. So Monticola robust plant. So in these combinations also we got very good various different characters. Then VRA 10 Monticola. Then VRA 6 Beta-saccharide. So these are all the another genotypes, another hybrids we developed from the wild species. Now it's maintained in the regional research station Viruthachalam. So these are all the characters we considered for crossing program. The important yield contributing characters. Ground rate concern, direct traits are there and indirect traits are there. Direct traits, pod yield per plant. We have to consider. Actually, intraspecific hybridization totally we have to consider for yield and all. Whereas the interspecific hybridization, when you go for only transferring genes, biotic and abiotic resistant genes transferred to cultivated types. So number of parts per plant, shelling percentage, one of the main characters for varietal list purpose, sound matured kernel, that is also important. Then 100 seed weight. Indirect character is concerned in harvesting peak strength and shelling. So number of seeds per pod. Reticulation also one of the character. Peak and constructions of the pods. So this is these two are the varietal characters for it is used for seed certification people. Kernel shape and color, freshy dormancy, balancing ability were also considered to certify farmers, processor and marketers. These are all the indirect traits, indirect characters, and direct characters we considered for crossing program. So to improve the peanut crops, especially our varieties, genes from wild species can be introduced by backcrossing, hybrids with Arachis hypogaea, and diploid species whose genomes are similar to those of cultivated peanuts are crossed. Sterile hybrids were results artificially doubling the number of chromosomes of these hybrids, resulting in fertile synthetic polyploid. Objectives of our studies to obtain the progenies by crossing with wild peanut similar to cultivated groundnut to characterize these advanced resistant program progenies for further evaluation to forward the generations. So material. So this is another set of material we are using. Apart from VRA 9, VRA 10, VRA 8 and VRA 6 also we used. So wild species is concerned Manticola, Pusilla, Patricica, Villosa, Stenoperma, Cardinaceae. These are all already I showed. What is the type of phenotypical nature of the particular species and varieties. The present study used for groundnut varieties. So all VRI6 in the Mandicola, VRI6 in the Pusilla, VRI6 in the Platycicola. Likewise, we are crossed with all the varieties with all the 6 wild species of Arachis. So VRI10 and wild species Mandicola, Arachis pusilla, Arachis platycicola. Likewise, crossed and proceed for subsequent generation. All 4 varieties crossed with all 6 wild species mentioned. All wild species are crossable to Arachis hypogaea. So most of the literature says in a groundnut. So F1 is look like wild species. I don't know what about Mendelian genetics worked out in the crossing program. So many studies, whether they are checked fully or not, I don't know. But many literature says the cultivated species into wild species. F1 is cultivated. F1 is some genotype of wild species. How it's come, I don't know. How it's come, I don't know. So most of the literature says the same things, but mine is different. So intermediate type is available. Intermediate type is available in F1. So I selected that plant and forward the plant. I got excellent progenies. I got excellent progenies in forwarded stages in groundnut. A total of 24 crosses were made. F0 state, all the cross combination produced and crossed parts. In all the varieties combined with the Monticola recorded highest part set in F0 generation, followed by Pusilla, Batisicoi, and Villosa. In all cross combination, maximum fertile efforts were recorded, apart from sterile plants. Sterile plants also is there. For study purpose, we are maintaining that plant. But we have to, during harvest, we have to reject it. There are true efforts as given variable size of parts, plant structures, height of plants, the earliness, deviated from both parents and expressed intermediate plant type. Received diversified variations observed in the F1s, followed by F2 generations of all cross combinations. All cross combinations. Hybridization, female parent seeds or groundnut seeds. This is how to sowing the F1 seeds. F1 seeds, that information I'm giving here, this is totally agronomic point. So you have to do the first line parent, middle line hybrid seed, third line parent. This way, if you raise F1 generation, you have to compare both parents and you have to identify true F1 in field itself. It is very easy to identify the or fix the true F1 hybrids. That is the good for all breeders. So they are raising the F1 parent here and F1 other places. So it makes confusions. We are not getting clear that idea about on the particular cross combinations F1s. So if you parent, one line, additionally second line is the hybrid, third line is the another parent. That is good for us. So artificial hybrids, how we are making and produced. So cross part set and crossability percentage Arachis hypogaea, germination percentage and F1 hybrids. This slides the parents of parental seeds, number of seeds germinated, percentage of germination, number of seeds attended at maturity. This is the variety and perennial. These are the perennial. We need not scoring of number of seeds germination and all. Only parent we have done. Next, crossed seeds, how it's germinated and germination percentage, and crossability percentage ranged from 4% to 29%. 4% to 29%. The 29% only in the Mandicola and Clavirata. Mandicola and Clavirata, So both are having 2 and 40, so that there is no problem at all for crossing. So other species lowest 4% to 6%, 7%, something like that. So this is the slide for crossability percentage and number of genes eliminated, hybrid lethality, hybrid breakdown, so generation percentage, genes attain the maturity. So all the particulars I am giving here. So all those things, the Manticula is the best for all cross combinations. Because of the homology of a chromosome, between the Manticula and Arachis hypogaea. Then evaluation of F1 hybrids. Even evaluation also, the both female parent and another parent, we have to check for a checking purpose. We are always raising F1 along with parents to easily identify the true one F1. Then pollen fertility also judged. So fertility actually it is there. So already we have rejected during harvest. Sterile plants we have to reject it, so that only fertile plants we have taken for consideration, and we are forwarding the generation. So pollen fertility also it is there up to 70% it is there. So conclusion for groundnut. So whatever may be in the cross combinations, wild species cross combinations, carefully you have to do. So we are going to get full-fledged plant types, we cannot get it. So partial sterilities comes. So very few fertile plants are comes. So because of groundnut is the polyploid in nature. So gametes, how it's formed, as a breeders we know. So the connection of or union of the gametes, based on the union of gametes, univalent, multivalent, bivalent, divalent, all valencies comes in that. So according to that valency, the sterilities come and fertilities comes in the F1 generations. So we have to consider. So crossability is there. We have to try, definitely we can get it. So my opinion, if you cross one cultivated type to another wild species, the F1 is sterile means you have to try more number of varieties with, so at least one varieties comparable with combined with a particular wild species. Definitely we cannot go, no need to go any other way methods. Biotechnological method we cannot go. So if you use whatever biotechnological people doing or other people doing, finally they are coming to conventional breeding methods only for improving the such varieties, improving the varieties. So whatever may be the things doing outside, again come to, so that I decided for this program, conventional breeding approach is very good for our breeders. So that I am taking that point. So my view is conclusion of this particular study. So more number of species involved, definitely we can get successful hybridization. So next we are going to see mungu bean. So 2 crop I mentioned. So today one crop over and another crop mungu bean. Mungu bean. So this is anchor. Hello.
Yes, sir.
Hello. Now I am going to
डॉक्टर साहब
मूंग bean.
हाँ प्लीज कंटिन्यू करिए आप,
Okay,
बड़ा
okay,
अच्छा लग रहा है,
okay.
मैं बड़ा गंभीरता के साथ सुन रहा हूँ सर इसको,
Okay,
बहुत
okay.
अच्छा लग रहा है मुझे, काफी डेप्थ में आप जा रहे हैं, मैं एक एक चीज नोट कर रहा हूँ, आप प्लीज कंटिन्यू
So
करिए.
in this study, first I have done only 6 species considered for improving mungu bean. So in mungu bean, This is also one of the food crop. North Indian, they are taking more Vigna radiata, that is mungu bean. So South India is concerned, black gram is most used by the consumers. The idli dosa making, they are using black gram as compared to green gram. Green gram is a versatile crop. Versatile crops. So only things, two problem is there. One is yellow mosaic virus susceptibility and also bruchid susceptibility. So bruchids invariably in all crops affected. In that, so black gram is concerned, there is no problem at all for yellow mosaic virus disease susceptibility because I developed so many varieties. So all the varieties from 2000, sorry, VRI 4, VBN, that is Vamban Center VBN 4 to VBN 8 developed by me and released to Tamil Nadu and also All India level, South Zone, All India level, South Zone. In that, there is no problem of yellow mosaic virus disease. That also I wide cross combinations, I did it by Silvestris, the black gram into Silvestris. The first state varieties with wild background, I am the person released, and also for All India level, South Zone, the first varieties with wild background, I am released. So there is no problem at all. Whereas in green gram, yellow mosaic virus is the problem. Still it is there. World level, there is no 100% durable genotype is not available, especially for yellow mosaic virus and also bruchids There is no resistant source. But one species, Vigna vexillata, it is available in the Himalayan region. So that species having both yellow mosaic virus resistant and also bruchid resistance, Vigna umbellata. In other species also take into consideration for crossing purpose. So Vigna radiata or sublobata, Vigna mungo or silvestris, Vigna hainiana, Vigna umbellata. Many other species are there. They are only restricted to the 6 cross combinations. Today I am focusing. So out of 23 species available in India, especially for Vigna species, so 18 species I involved, I cultivated Vamban center itself. So analyzed for many more years. I observed only one species, Vigna umbellata, is having durable resistance, fixable resistance. So that I used this species Vigna umbellata with Vigna radiata for crop improvement program. So Vigna sublobata, Vigna silvestris. Vigna sublobata is a wild progenitor of Vigna radiata. Vigna mungo or silvestris is a Vigna mungo is the wild progenitor. So Vigna hainiana, this is similar to Vigna radiata. Vigna umbellata, somewhat different from, morphologically different from Vigna radiata. Vigna vexillata, it's a tuber crop. It is a tuber species. Vigna radiata. Indian species are there and African species are there. African species are having edible tuber. Then Vigna trilobata. Trilobata, you know, invariably in all places of India, Vigna trilobata is available. Vigna trilobata. Aconitifolia, you know, the moth bean, that is also available in throughout India. So likewise, many species are there. Some of the minor species we consider as a minor pulses. So interspecific hybridization, this method, the boiling and co-worker methods I followed. The invader pollen growth, this fellow James and co-workers methods I followed. So I find out hybrid lethality, cytological observations, cytological behaviors and the irregular behaviors are there observed in the cross combination, and the F1 generation, 12 quality characters studied, especially for interspecies hybridization, pollen fertility. For intraspecies hybridization, more than 18 18 characters I studied. Then pollen fertility, confirmations of F1 by isozyme and also SSR marker. I also SSR markers I used for my industries hybridization study. So here you can see wild species of Vigna. So this is Radiata, Sublobeta, Silvestris, Hyliana. This is Exilata, Umbellata, and um, Sublobeta. So all the species we are seeing now. So it is all similar to green gram based. So these are all the species I involved for. So crossability percentage is here 2.58 to 21.92. 21.92, whereas in groundnut 29. So Vigna radiata and Vigna radiata or Sublobeta 29 means this is the Sublobeta is a wild progenitor of green gram. So that highest level. So Vexillata reciprocal crosses 2.5 only. Vexillata into radiata. Vexillata is the wild progenitor of cowpea. Vexillata is the wild progenitor of cowpea. So that it is variation is more. So that less percentage, crossability percentage 2.85. Hybrid germination 80% Vigna radiata into Hyliana, 12% Umbellata into radiata. So this is the important point in the pollen germination. So you can see here, this is radiata into Umbellata, F1. This is radiata. This is radiata into Umbellata. So this is parent. The middle is the parent. So above is the hybrid. So pollen germination, how its behavior, it is there. So radiata and Umbellata 0% pollen germination. Where in one variety involved for Umbellata cross combination. Another variety fertility is there. Another variety crossable with Vigna radiata, fertility is there. So I will show later. So this is the fertility of F1. Fertility of F1. Here you can see. This is two. This is parent. This is parent. This one is Umbellata. The first two picture parental pollen fertility. The last picture F1 sterile pollens. Maximum sterile pollens are there. The Vigna radiata and Umbellata sterile pollen. So that means F1 is the sterility. So plant look like medium intermediate type. The both parent intermediate types. The F1 is 2F1, but sterility is occurred. Here, female sterility and male sterility is also it is occurs in that. Female sterility and male sterility. So cytological approach for why this sterilities comes. Why this sterilities come between Vigna radiata and Umbellata. So already I told univalent, bivalent, quadrivalent, and multivalent. These are all the valencies occurred in the gamete formation. So automatically meiotic behaviors, chromatin is happened in that. So myself in the F1 generation. So here you can see. So dyad formed first slide, first picture. Second picture clearly formed. Third pictures, but tetrad also formed, but it is not separated because of non-separations of tetraploid, tetrad, non-separation of tetrad. So sterility has comes. So fourth picture pentaploid. So 1, 2, 3, 4, 5 pentaploid, then hexaploid, then octaploid. All such kinds of things are available, so that sterility, male sterility comes into that in F1. For male sterility, why it comes? These are all the problem. These are all the reason. So instead of bivalent development, all the valency was there. All the valency, univalence maximum and multivalence maximum. Multivalence maximum. So that the F1s getting male sterility. Male sterility. Study of F2 generations of interspecies crosses, Scanos, Kurtosis. This is a common things based on the characters, quantitative characters we can assure. So some pictures I can show. So this is the field view. P1 is the parent one, P2 is the parent two. That is P1 is the grain gram, P2 is the sublobeta, and middle is the hybrid. Same as I will show many. So this is F2 from this F2 generation forwarded material. Then another cross combination, Silvestris. Another cross combination, Silvestris. Then Vexillata. Then Vexillata P1, P2, middle is the F1, Vexillata. So if you see here, the Vexillata having tuber in nature. Tuber in nature. Clear cut, clearly you can see. Bodies look like cowpea. So big size pod with the dense of hairs. Dense of hairs. So as per resistance, that is pest resistance, the Vexillata having somewhat some percentage resistant to bruchids. Resistant to bruchids Vexillata. Then Trilobeta. Trilobeta, the F1, F2, sorry, F1, P1, P2, middle is the F1. So in the middle F1, I understood that plant is somewhat different, but the pod look like similar to male parent, Trilobeta parent. But in F2 generation only, I could get a lot of variants in F2 generations. Then only I confirmed that this is the hybrid, true hybrid. So this is the progeny of F2 progeny from Trilobeta and green gram and Trilobeta. So resistance for intra and interspecies crosses, bruchid resistance, PRMG 1 into yellow, umbellata into radiata, 31.65, radiata into Vexillata 31.65. So my studies among these species combined with Vigna radiata, the radiata used as a female parent easily crossable with other species. Already I told Vigna umbellata is having both resistant, yellow mosaic virus and bruchid resistant. So that I used extensively that species into green gram improvement programs. Green gram improvement programs. So one thing I want to tell, even in F1 generation, there is no yellow mosaic virus incidence in umbellata into radiata crosses. Umbellata into radiata crosses. So other picture you show, you know. So parent radiata affected by bruchids, but umbellata not affected by bruchids. Even parent also not affected, and also F1 also it's not affected. So this is umbellata into radiata pictures. So donor development, MOM resistant donor through wild gene incorporation. Green gram MOM donor I developed through Vicna radiata into umbellata. The F1 showed the intermediate characters of both parents. F1 hybridity was confirmed by rice bean marker GED 263 developed by NIAS, Japan, stabilized interspecies hybrids lines from radiata into umbellata as international MOME resistant donor. And MOME resistant donor in green gram derived from wild recombinant of Mungibin name as given. VGGRU1 is already registered in the conserved in the NVBGR, Vigna radiata into umbellata cross combinations. Bird first donor I developed. So the hybridity hybridity is tested with GED 263 primer in Japan lab, NIAS lab. So this is markers based on the rice bean markers. Then outcome, this is the plant. They developed the complete yellow mosaic virus resistant genotypes from Vigna radiata into umbellata. So still all the 12th generation, there is no any expressions of one tinge of or a dot of OME dot is not in the plants. So for Mungubin conclusion, biotics test Burkitt's MOM input through the interspecific process, especially Vigna radiata, highly compatible with all wild Vigna species. So Vigna radiata and Vigna umbellata always helpful to the Mungubin improvement breeding program. The breeders easily can get the both yellow mosaic virus resistant and also Burkitt resistance. If you go for with this species, definitely you can improve the things. Thank you, one and all. If any questions, please. Anchor. Hello. Hello.
Hello.
Madam,
Hello.
over.
हाँ प्लीज कंटिन्यू.
Yeah.
पूछिए.
With this completed.
नहीं कोई क्वेश्चन एक पूछ
So,
रहा था मैडम
yeah.
साइड.
Conclusion, I want to tell you. So both crops, if you use many more varieties with wild species, definitely you can get F1 fertile plants for improvement program. The both side, both the crops, I can say. You need not go for any other biotechnological tool use. So right away you can get all those things. Very good fertile plant you can get if you do more number of genotypes used for crossing purpose with wild species of respective crops. This is my conclusion. So some breeders choice. So we are using this species to that species. We are not getting F1 fertile plants. So it is very difficult to recover fertile plants. That is the thing. In that case, we have to go for more number of varieties or more number of genotypes used for crossing program without any difficulty. If you do things, definitely you can get it.
नेक्स्ट प्लीज. किसी को यदि कोई क्वेरी है किसी की इस पर्टिकुलर टॉपिक से रिलेटेड तो आप सर से 1 to 1 बात कर सकते हैं. डाउट क्लियरिंग सेशन है 5 से 7 मिनट का. कुछ पार्टिसिपेंट्स का मैसेज है कि डॉक्टर साहब आज गणेश चतुर्थी है तो हो सके तो थोड़ा जल्दी वाइंड अप कर दीजिए. तो किसी का कोई क्वेरी है तो आप प्लीज पूछ लीजिए, फिर इसको खत्म करते हैं.
Another one important point wanted to tell you, especially for breeders. So some of wild species not having 100% durable resistance for yellow mosaic virus or Burkitt resistant. If you cross with that particular species, but sometimes likely you got for cross combinations a recombinant, strong recombinant material you got it. I achieved in the background cross combinations. I already told you 2 varieties released with wide background, Silvosis background, black gram into Silvosis. So Silvosis having not 100% yellow mosaic virus resistant, but recombinations tight linked genes of yellow mosaic virus resistant genes, tight linked to the green gram, black gram, so that all the varieties are 5 varieties released from that background, but 2 varieties are very promising, 116 and 118. 116 and 118 very promising. Now it is available in the farmers field. For 118, especially 118 is concerned, it is bypassed to Tamil Nadu and to Andhra. Now it is occupied Andhra Pradesh because of yellow mosaic virus resistance. durable resistor. So sometimes recombinations means F2 you can get it, F3, F4, F5. So in that processing period, definitely strong resistant genotypes we can get it. So continuously we have to do, otherwise we cannot get it. So this is another point I want to express it. Thank you.
Sir, good evening, sir. I have a doubt in breeding
Answer me,
aspect.
madam.
Sir, regarding sesame crop,
Ah.
um, uh, so it could exploit heterosis in a very good manner. What is the reason for why the hybrids are not successful, or why so far hybrids are not released when compared to other cross-pollinated crops? Though it is self-pollinated crop, the cross-pollination extent is up to more than 35%. And what's the reason behind the not successful production of hybrids, sir?
Madam, we tried for CMS based lines
Okay, sir.
for hybridization. For heterotic vigor, we are tried on the that way, but it
Okay.
is not success. It is not success. It is often cross-pollinated. It is not self-pollinated. It is comes under
Okay.
often cross-pollinated because epipetalless nature. But what is
Okay.
the acute problem for not making hybridization? We
Mm.
are doing only hand emasculation and hybridization. That is the
Okay.
problem. So for
Sir, but
exploited many lines through in our research station. Previously, I was head there. Region research
okay.
station, Viruthachalam. We tried
Okay.
one scheme was obtained from DBT and we did it, but could not success.
Sir,
So
but the male
100
sterility system was also
male
available there in
sterility,
certain states.
100% male sterility plants are not available, madam. That is the problem.
Okay. Okay.
That is the problem.
Whether
If
the
100%
transferring,
male sunlight is available, so male Malabar economy,
yes, sir. Yes, sir.
Malabar economy is the source of
Male sterility system.
Ginjali. Ginjali is concerned, that is the main source, but it is
Yes,
not
sir.
success.
Sir, whether you have tried by doing with the cultivated species, and whether you have done any backcrossing program to incorporate male
Yeah,
sterility system.
we are doing at that time we are doing, madam. We are
Okay, sir.
doing. So if you go for any hybridization programs or transferring genes means definitely you have to go to Wegr's method only.
Okay.
Wegr's method in all crops you are using. All crops you
Okay,
are
sir.
using. This is the problem. So
Okay.
Allatum is there.
Okay.
Allatum and other many species are there.
Okay.
But the problem is only hand
Mm.
emasculation and hybridization. Pollination is the problem for obtaining heterosis. Cost benefit ratio, it is not favorable.
Okay. Because of hand
So
emasculation.
very good heterosis is there.
Yes.
Sometimes some genotypes crossed with another genotype.
Mm.
100% we can get heterosis vigor is there in F1
Okay.
generation. Only
Yes, sir.
thing hybridization, hand hybridization pollination is the problem for heterotic
Okay.
vigor.
Since
So
we could not able
cost
to
will, yeah.
we get a stable sterile genetic male cell system, it is maybe the problem.
That is the problem. Another thing, labor cost. When you go for
Mm-mm.
hand emasculation and
Mm.
hybridization,
Mm.
so cost is more than that of seed cost.
Okay.
Whatever
Okay.
cost we obtained in the F1 generation,
Okay.
this cost value
Mm-mm.
is very small than the labor cost. So that is
Okay,
the
sir.
problem in that.
Okay. Okay. Okay, sir. Thank you.
Oh, thank you, madam. Any other? I think it is interesting subject. Madam is asking very good question.
नंदिनी कंक्लूड करिए. नंदिनी, आप सुन पा रहे हैं?
हेलो हेलो सर, आवाज आई मेरी?
हाँ हाँ हाँ।
On the behalf of entire AgriMeet Foundation Bharat, I extend my heartfelt gratitude to our esteemed speaker, Professor Dr. M. Pandyan, for gracing all of us for the today's session and his presence with all the knowledge and great wisdom. Sir, your inspiring journey and everything you told us about the breeding and genetics and everything, and the work you are doing and the work you have done, it has inspired a lot. The knowledge you have shared with us today had a great impact on all of us, and it also motivated us to do something in our lives, and we are grateful for your presence. Thank you so much, and we'll be needing your support in our all the future activities, academic activities. Thank you so much, sir.
Thank you,
डॉक्टर साहब
madam.
बहुत बहुत धन्यवाद।
Thank you. Actually, I am grateful to associated with Dr. Ankush Sharma
सर
because
सर
I
सर,
got
माय
the chance.
प्लेजर सर।
No. Anyhow, I would like to say thanks again to Dr.
आई एम
Sharma,
जस्ट
Ankush
लाइक
Sharma,
योर सन ओनली सर।
for giving me the opportunity. I am always with you. I please give the chance again. I will tell my views for improving our society. I am
गुरुजी,
once again I
आई
am
एम
very,
जस्ट लाइक योर सन, कीप योर
yeah,
ब्लेसिंग्स
that
ऑलवेज।
I am again
कीप
I
योर
am very
ब्लेसिंग्स
sorry
ऑलवेज।
for not again I am very sorry for not attending the first day presentation because I have
नहीं 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 सर,
I
सॉरी
have
की कोई
important
जरूरत नहीं है
engagement.
सर। जी जी
Yeah, at that time
जी।
I was in the journey, so that I could not realize that. So I could not attend the presentation on the day. Once again, I am extremely sorry for the inconvenience make in that.
डॉक्टर साहब, आपसे बार बार
Anyhow,
गुजारिश है कि सॉरी बोल के मुझे डिमीन मत करिए आप, प्लीज।
yeah,
आपकी
anyhow, thanks
ब्लेसिंग्स चाहिए
for
मुझे, ऑलवेज ब्लेसिंग्स।
my blessings always to our all scientists who are all
डेफिनेटली।
joining with Agri Foundation. Definitely, with God graces, I am telling always best wishes to all of you. Again, thanks one and all for
एंड हैप्पी गणेश
my
चतुर्थी
lecture.
सभी को। गणेश चतुर्थी की बहुत बहुत शुभकामनाएं मेरी तरफ से।
Yeah, that itself I am very happy. Today I got the chance.
जी 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 जी।
So thanks one and all. Thanks, Ankur. Thank you.
ओके डॉक्टर साहब, ओके डॉक्टर साहब, ठीक है ठीक है। सभी पार्टिसिपेंट्स लेफ्ट कर सकते हैं। जय श्री राम, जय श्री राम।